in this video, we are going to talk about the equations of circles and parabolas and how they are related to each other and how they both actually stem from these equations right here, which are actually the same equations. The Pythagorean theorem, we've talked a lot about this year, a squared plus b squared equals c squared. And that's where a and b are the lengths of the two right angle sides of the triangle. And then c is the hypotenuse. Now the distance formula is something that really is the exact same thing as the Pythagorean theorem, where this is like the distance going left and right. This is the distance going up and down that you would take to get from one point to another. And then that gives you the diagonal distance between those 2 points. So let's look at how those things play into the equation of a circle. So if we're looking here, we have a circle, and you can see that the center is at 3, 1, and this point over here is at 8, a little before 2 it looks like, or a little before 8, kind of at 2. This point right here. So what we can do is we can write the equation of this circle essentially using this distance formula. The left to right distance between this point and this point is going to be the x-coordinate of this point subtracting out these 3. So that's where we get x minus 3 squared for the left to right distance. The up and down distance is essentially going to be the y-coordinate of this point minus this little bit right here, because that's not part of our triangle. So it's y minus 1 squared. And that, if we have y minus 1 squared plus x minus 3 squared, is going to give us the radius squared. You can see how we have our right triangle right here. And so we're essentially just using this side squared plus that side squared equals r squared, which is just the Pythagorean theorem, or we can also think of that as the distance. It's the formula that gives us the distance from there to there. That's how we get the equation of a circle, which we've been talking about. This would be the center of the circle, 3, 1. R is the radius of the circle. Now we just know that it actually comes from this distance formula. Now over here, the equation of a parabola also uses that same idea of the distance between 2 points. Here it was this point and this point. Over here it's going to be the focus and the point on the parabola. To get from one point to another, you would travel here and then up. You go across and then up. So this across and this up distance make a right triangle with this distance as the hypotenuse. So really we're just using, again, the Pythagorean theorem or the distance formula to describe this triangle. So the going across distance is x minus 1 squared. Here is x minus 1, because this is the x-coordinate. And then you would subtract out this 1 over here to get the distance from there to there, because this over here is not part of the triangle. So this distance is whatever this x-coordinate is, subtract out that 1. So that's where we get x minus 1. The up and down distance of this right triangle here, this little bit right here, is going to be whatever this y-coordinate is, but we're going to subtract out this 4 because that 4 down there is not part of the triangle. It's just this little bit up there. So this y-coordinate minus these 4 give us whatever this distance is. So now we have x minus 1 squared equals x minus 1 squared plus y minus 4 squared equals this distance, y squared. Now, we know that by the definition of a parabola, whatever the distance between the focus and the point on the parabola is, that's also the distance between the point on the parabola and the directrix. Which means that we can write our equation like this. X minus 1 squared plus y minus 4 squared, that's this and this, equals y squared. And we know that this is going to be the distance between this point and the directrix. Because the directrix is the x-axis right here, we know that it's this full distance. We're not subtracting anything out. So that's why we say y minus 0. It's 0 because the directrix is at the x-axis. It goes the whole length, nothing is subtracted out. If the directrix was, let's say, up here at 1, then over here we'd have to say y minus 1 because we'd have to subtract out this bottom unit and it would just be that distance right there. So this is the equation of a circle over here. And it looks very similar to the equation of a parabola because they both kind of build on this idea of the distance between 2 points, either the center and a point on the circle, or the focus and a point on the parabola. The difference is that over here, this is the radius, it's just going to be a number. Over here, we're going to have this little expression that tells us essentially where the directrix is. So let's use this down here. Let's say we had this equation of a parabola. This tells us that the focus is going to be at -3, +2, because it's always the opposites of those. So that gives us what the focus is. And we also know that the directrix is going to be the horizontal line at y equals 1, because that 1 right there tells us that. It's going to be the opposite of what we see there. So we can get this information about the parabola looking at this equation. But what if we want to know what the vertex is? To do that, we would have to rearrange this into vertex form. So think back to algebra. And we talked a lot about quadratic functions, and we talked about vertex form was one of the ways that we could write them. There was vertex form, factored form, and standard form. Vertex form gives us the vertex. So we're going to try to make this look like this, and it's not actually as difficult as you might think. It's actually pretty straightforward. The first thing we're going to notice in our quest to make this look like that is this has an x minus h squared in it. So that's great. We're going to leave this alone because this is essentially going to turn into that. So the h will be like a 3. Okay? However, there is no y squared in here. So what we need to do is we're going to multiply this out and multiply this out because there's no other parentheses. So in our quest to make this look like that, the first thing we're going to do is we're going to multiply these out to get rid of those parentheses. So I'm going to rewrite it like this. X plus 3 squared. Now I know that this is a perfect square. This turns into a perfect square trinomial from using those box things. And so that would actually turn into y squared minus 4y plus 4. If you're not sure how that turned into that, refer back, I think, to video number 3 and maybe 4, and we talk a lot about how this goes back and forth between that using the box method. On the other side, this squared binomial here turns into y squared minus 2y plus 1. Again, if you're not sure exactly how that turns into that, refer back to one of the previous videos. I believe it was video 3 or 4, and then you can see what's happening there. Now, once you're good with that, we're going to just kind of start rearranging some things. Notice that both sides have a positive y squared. Those cancel out. So now we don't have any more y squareds. That's good news because there's no y squareds down there. Notice, though, that we have a y on both sides. So let's go ahead and get the y on one side together, and let's get it on the opposite side of this, because over here, the y is by itself on the opposite side of our parentheses squared thing. So I'm going to add 4y and add 4y. Notice that I wrote them right underneath, and if I draw a line, I can see that I have two separate sides of my equation. If I add 4y over here, I also need to add 4y over there. And I wrote it right underneath the y terms on each side. That way I don't get confused about what I can add it to. So that cancels out. And I'm going to rewrite my equation now. On the left side, I have x plus 3 squared. That canceled out. That's gone. I just have the plus 4. Equals, I have negative 2y plus 4y. That's a positive 2y plus 1. This is looking pretty good. It looks a lot like that. Okay, I have my square term. I'm adding something to it. Over here, though, I just need it to be a just plain y, and that's not what I have going on. So I need to get rid of the 1 and the 2. So first I'm going to undo the plus 1. So I'm going to subtract 1 on both sides. So now I have x plus 3 squared. 4 minus 1 is 3 equals 2y, because that canceled out. Now I'm just going to get y all by itself, so I'm going to divide both sides by 2. Okay, so now on one side I have a y. On the other side, I'm going to divide each of these by 2. Now, this first one, when I divide the x plus 3 squared by 2, I'm actually going to multiply it by 1/2 instead. So it looks like that. Only because dividing by 2 and multiplying by 1/2 are the same thing. And this way it looks a lot more like this, because now I know that my a value is 1/2. Then I have my x plus 3 squared. And then I'm going to divide the 3 by the 2. And 3 divided by 2 is 1.5. So that would tell me that if I were to graph this, my a value would be 1/2. And the vertex would be at the point -3, 1.5. So we can see that this is the equation of a parabola. These 2 points give us the focus, opposites of those. This gives us the directrix. This is y minus 1, so the directrix is at y equals 1. And then we can rearrange it also to find the vertex. I hope this video was helpful. You can always come to the meeting on Wednesday and I can answer any questions. Try the practice and see how you do.